501 Genesee Street, Rochester, New York, 14611. Alright, send that right off. Oh, hi, Miss Worth.
Hi, Mr. Webster. How you doing?
I'm good.
You sending something off in the mail?
Yeah, I was just addressing this envelope. I'm sending out some thank you cards.
Oh, and you had to have the right address, I'll bet.
Right, otherwise you don't know where, the post office doesn't know where to deliver it to.
Absolutely. And what do you have on there? You have a name, you have a number,
Yeah, street address, a number.
and the city, and the state, and the zip code.
Right.
So you have very specific things. And basically, that's what we're going to be talking about today. We're going to be talking about the electron structure for a change. You know how you guys have been talking about atomic structure? Well, now specifically we're going to look at electrons. And electrons have their own little address as well.
They have a little postal service too?
Sort of. Well, scientists have found out that it's very important to know where these electrons are at all times. Because what it's going to do is it's going to help them be able to predict the bonding in molecules and then physical properties in elements. So it's very important to know where these electrons are.
The electrons help us know which molecules are going to bond with which and all the other properties that go along.
And how they'll behave when they find each other and that kind of thing. So let's get started. Just like addresses, electrons have places where they belong. And what they want to do is they want to find a space that has low energy, lowest amount of energy, and that basically is alone by themselves. They don't really like to be near each other. Why do you suppose that is?
Well, we learned that whole thing about the negative charges repelling each other.
Right.
Okay.
So they don't want to be in the same space, but sometimes they have to share a space because they're in the same energy level. But what electrons want to do first is definitely go into a space that's by themselves and in the lowest energy level. Sort of like getting on a public bus. You know, the first thing you want to do is you want to scope out an empty seat.
You find the empty seat.
And you also want to find the empty seat that's closest to the door. So
Right.
you don't have to go too far, you don't have to expend too much energy to get out of the bus when you're leaving.
Right.
So you want to get to closest to the door, least amount of energy, and you want to get in the seat by yourself.
Right.
And then somebody else comes on the bus, and what are they looking for?
They're looking for their own seat by themselves.
And closest to the door.
And closest to the door, right.
Right? And until all those seats have been filled, do you actually then double up?
Right.
Okay? Same thing with electrons. When you're looking at the hydrogen symbol on the periodic table, we learned that this number down below represents how many electrons you are and where the electrons are. This one right here is saying that there's one electron in the hydrogen atom, and that one electron is in the first energy level. Remember what I said about energy, and that the electrons are going to go into the lowest energy spot. So this would be the lower energy, and then this would be higher energy. Notice how I'm showing this electron as an arrow, and that only means that the electrons are spinning around, and that electron has its own little spin. So it's just all by itself, it's going to be spinning in one direction. And we usually say that if the electron's alone, it's spinning in the up direction. Again, hydrogen has one electron, and it's going into the lowest energy level. Helium, there's the two electrons that helium has, and the two electrons are in its own energy level. It wants to take up the lowest energy level before it's going to go into anything higher. So what scientists do to demonstrate where those electrons are, they show them as arrows. In the lowest energy level, they want to fill that space with the lowest energy first before they move up to anything higher. And since there are only two electrons for helium, those electrons are going to be found in the lowest energy level. And notice that those electrons are spinning in opposite directions. Because they have the same charge, they want to repel each other. So notice that there's two electrons that can be found in one space together. One spinning in one direction, one spinning in the opposite direction. Moving along the periodic table, the next thing you come across is the lithium. Lithium says that it has 2 electrons in the first energy level and 1 electron in the next energy level. So how are we going to show that? Notice that those 2 electrons in the first energy level are spinning in opposite directions, and then I have one more electron I have to show, and it has to go, the only place it can go is to the next highest. It's not going to go any further than that. It's going to go to the least, the space that has the least amount of energy first. So that third electron is going to be in the next energy level all by itself. What I thought I'd do is do a practice one with you. So let's move to boron. Boron has 5 electrons. Notice I've already filled in 4 of them. The 2 that are in the first energy level, and then the 2 that are in the next energy level. Boron needs to be showing 2-3. Right now I'm showing 2, these 2, spinning in opposite directions, -2, 2 more. So where's the next electron going to go? Well, it has to go to the next spot that has the least amount of energy. And that's going to be closest to here. Okay? So that third electron is going to go into the next spot up, but still has the lowest amount of energy. So the electron address includes the energy level that it's in, the sub-level that it's in, or the subshell, and then the number of electrons that are in each of those subshells. Okay, so there's its address.
All right, so I understand how the those little squares you're putting up are kind of like an address, and they tell you, what the atom would look like, where you'd find the electrons. And I understand the idea is kind of like a bus. It fills up front to back, and they're trying to get some space from each other. But I guess my question is, when is the bus full?
So the first energy level holds as many as 2. Second energy level holds as many as 8, remember. But remember that there's 2 electrons that are a little bit lower in energy than the other 6 that are over here.
So that whole top part can hold 8.
Yeah, add them up. There's 2 here, 4, 6, and then 8. So there's a total of 8 electrons found in that second energy level. And so on and so forth, even if you go up to the third and fourth energy levels.
Oh wow, that makes a lot of sense.
Good. I hope it does to you too.
Let's get on the bus.